Hello viewers, in today's class we are going to discuss one important definite integral involving absolute value function, right? So let us start. So here we have to integrate uh, absolute value of cos pi x from -2 to 2, right? So let us call this integral as I, right? Now here let us denote this function by f of x, that is equal to mod of cos pi x, right? Now if we replace x by minus x, we see that f of minus x is equal to mod of cos pi minus x, and we know that cos of minus theta is equal to cos theta, right? So f of minus x is equal to mod of cos pi x, right? So there is no uh, a change when we replace x by minus x. So this shows that f of x is equal to f of minus x, and this implies that f of x is an even function, right? Okay, so now we have established that this is an even function. So now we can use the important property of definite integrals, which says that uh, if we have to integrate from minus a to a f of x dx, and if f of x is even function, then this integral is equal to twice of the integral from 0 to a f of x dx, right? So now the original integral I can be written as 2 times of integral 0 to 2 and mod of cos pi x dx, right? So here a is 2, right? So the value of a is 2. Now we have to solve this integral. Now before solving it, let us first find out the critical points. So let us solve the equation cos pi x is equal to 0, right? So now in order to find out the critical points, we have to solve this equation, and cos pi x is equal to 0, right? Now we know that the value of cos theta is equal to 0 whenever theta is an odd multiple of pi by 2, right? Where n is an integer, right? Okay, so now here theta is equal to pi x, right? So now we can write pi x is equal to uh, the odd multiple of pi by 2, and this pi and this pi get cancelled, so we are left with x is equal to 2n plus 1 multiplied by half, right? Now let us take the values of n, that is n equal to 0, then we have x is equal to half. When n is equal to 1, we have x is equal to 3 over 2, and when x is equal to 2, we have x equal to here 2 times 2 4 plus 1 5 by 2, right? Now see here the interval is from 0 to 2, and we see that when we take n is equal to 2, x is equal to 5 by 2, which is 2.5, and 2.5 lies outside this interval, right? So we'll take only these two values, right? So we see that now the interval from 0 to 2 is divided into these intervals, that is three intervals, one from 0 to half, other is from half to 3 by 2, and the third one is from 3 by 2 to 2, right? So it implies that we can now break this integral into the sum of three integrals, right? So I can be written as 2 times this is 2, and here we have three integrals I1, I2 and I3, right? And I1 is from 0 to half, I2 is from half to 3 by 2, and I3 is from 3 by 2 to 2, right? So now we have these three integrals. I1 is from 0 to half, I2 is from half to 3 by 2, and I3 is 3 by 2 to 2, right? Now we have to decide the sign of this function, right? So see, when x lies between 0 and half, then multiplying both sides or throughout this inequality by pi, we have pi x, and then we have pi by 2, right? So we multiply the whole inequality by pi, right? So we see that pi x, this angle lies between 0 and pi by 2, which is the first quadrant, and in the first quadrant cos function is positive. So here we have positive, right? It means mod of cos pi x is equal to plus cos pi x, right? Okay, now come to the second integral. So here we have the value of x, it lies between half and 3 by 2, and again multiply it by pi. Throughout we have pi by 2, here we have pi x, here we have 3 pi by 2. Now we see that this angle pi x is greater than pi by 2 but less than 3 pi by 2. So here we have pi by 2, and here we have 3 pi by 2, and this is the second quadrant, this is the third quadrant, and in the second and third quadrant cosine function is negative. So we have mod of cos pi x is equal to negative of cos pi x, right? So here we have the negative sign, right? Okay, now in the third integral, the value of x, it lies between 3 by 2 and 2, and again multiplying the whole inequality by pi, we have 3 pi by 2, here we have pi x, then we have 2 pi, right? So here we have 2 pi, and see this angle pi x, it lies between 3 pi by 2 and 2 pi, that is the fourth quadrant, right? And in the fourth quadrant cosine function is positive, right? Okay, so now here we have the positive sign, right? Now let us proceed further. So viewers, now we can rewrite these three integrals like this. So here we have the positive sign, because mod cos pi x is equal to plus cos pi x. Similarly here we have minus cos pi x, and here we have plus cos pi x. Now these three integrals are easy to evaluate. So now we know that the integral of cosine theta is equal to sine theta, and now we can write here the integral of cos pi x is sine pi x over pi, and the limits are from 0 to half. Here we'll take the negative sign outside. We have sine pi x over pi, limits are from half to 3 by 2, and here again we'll have sine pi x over pi, and the limits are from 3 by 2 to 2, right? Okay, now we'll simply substitute the limits and we'll take the difference. So now we can take pi outside. So now we have sine pi x 0 to half. Here we have sine pi x, and limits are from half to 3 by 2. Here we have sine pi x, and the limits are from 3 by 2 to 2, right? So now we can write here we have 2 over pi. Now here when x is half we have sine pi by 2, when x is 0 we have sine 0, and here when x is 3 by 2 we have sine 3 pi by 2, minus when x is half we have sine pi over 2, and here we have sine 2 pi minus sine 3 pi by 2, right? Okay, so now it is quite easy to evaluate this expression, because sine pi by 2 is 1, sine 0 is 0, and sine 3 pi by 2 is minus 1. Here sine pi by 2 is 1, and here we have 0 because sine 2 pi is 0, and minus sine 3 pi by 2 because sine 3 pi by 2 is minus 1 here, and this is the expression, right? So now we can write 2 over pi, and here we have 1 and minus 1 minus 1 minus 2, and multiplied with this negative sign, so we have plus 2, and here we have minus minus plus, so here we have plus 1, right? So we have 2 over pi, and here we have 4, and now this is 8 over pi, right? So viewers, the value of this integral is 8 over pi, right? So this is how we solve this problem.